Okay, we're in operation. We're going to do our heat pump refrigeration circuit review. So you have to bear with me. I have the film director behind me telling me what I have to do. Uh, so this is a review. And the top drawing, which you're familiar with, is a refrigeration circuit in the cooling mode. And so what we have is leaving the compressor, going to the reversing valve. Go back. We can say go back. So, they know you speak English. At any rate, the hot gas comes off the compressor, goes to the center to the single pipe of the reversing valve, and on this particular drawing, it sends it to the right hand side of the three pipe valve, going to the outdoor coil. And the outdoor coil, and I can do it this way if that helps. The outdoor coil takes the hot gas and condenses it to a liquid, and it comes out of the condenser coil and goes through an expansion valve. But in the cooling mode, the outdoor expansion valve is not a restrictor. It just goes straight through as if it wasn't even there. Then the liquid line goes inside, over to the indoor coil. It goes through the metering device into the indoor coil. The liquid boils off, comes out of the indoor coil as a cold vapor, and then we have the blue suction line going back to the compressor via the reversing valve. It goes in one of the side units. The reversing valve comes out of the middle of the three, goes through the accumulator, back to the compressor. So that's it. So in the cooling mode, it is the indoor reversing valve that is acting, as a metering device. The outdoor reversing valve is like it isn't there. Now we're going to go through. You don't get to see my lovely face. We're going to go down to the heating mode. The reversing valve redirects the hot gas going to the indoor, and so we're going through the large line, which is always the vapor line, both the cooling and the heating mode, going to the indoor coil. The indoor coil becomes the condenser, all right, and it condenses the hot gas to a liquid. It goes through the metering device, and in this mode, the indoor metering device does not restrict the flow. The yellow line is the liquid line, and the small line, the yellow line, is always liquid. The only difference is that it changes. Tell me something, dear, if you don't want to move it.
Closer to you.
Closer to me, okay. At any rate, the liquid goes in the other direction, going to the outdoor coil. The outdoor coil becomes the evaporator, and it goes through the metering device, and it restricts the flow, and we have the refrigerant going in there, and it evaporates. It absorbs heat, even though it's cold outside. It might be 30 degrees outside, but heat travels from a warmer substance to a colder substance. So if the evaporator is colder than the air, then it's going to absorb heat, and that's how a heat pump works. And then it goes out of that indoor coil again through the reversing valve, and then to the accumulator and back to the compressor. So I just want to make sure that you understand and try to remember which reversing valve. I'll put it a little back further so you can see it better. Which reversing valve is acting as a metering device in which mode. You should have that in mind. You should always remember that the large line is always the vapor line, either hot gas or suction, depending on what mode we're in. The liquid line is always the liquid line. The yellow line is always a liquid line. Now, I want to show you one thing here, that if you ever happen to, work on an old unit, I made a little drawing here. How are we? Can they see that, dear?
Closer.
All right. There we go. What I have here is the old units did not have the technology they have now, and the metering device did not have the capability to restrict in one direction and not the other direction. So I believe on this particular drawing I made, because I'm looking at it backwards, that I have the liquid coming in from your left, going to the metering device, but the metering device won't let it go through because it's the wrong direction. So it goes up the T through the check valve, pushing the check valve open, back down to the other side of the metering device, and off to the right. And that's the only way they knew how to restrict or not restrict. When you reversed it, then what would happen is the refrigerant would come this way, the check valve would close, and it had to go through the metering device and being a metering device. So they had this little bypass both inside and outside. There may be you may never see one, but sometimes on the old unit, especially if you get into somebody with light commercial work, that you might have to see them. All right. Now, one question we had, and it was on the quiz, heat pump always in the wintertime in the heating mode has lower pressures than it would in the summertime. And it was one of the hard things that I had to deal with when I was getting into heat pumps, because I always hated them. The entering air temperature, both on the indoor and the outdoor coil, is lower in the winter. The condenser coil is inside, but the inside temperature is somewhere around 75, 78, whatever you keep your house in. In the summertime, the entering air on the condenser coil is anywhere from 75 to 95 or 100. So summertime, it's a higher entering air on the condenser, and therefore the condenser is going to have higher pressures because we have higher temperatures. Likewise, on the indoor coil, on the cooling mode, we're running, say, temperatures going in at around 78 degrees or something like that. So that's going to have an effect on it when we boil the refrigerant off. When we go to the heating mode, the indoor coil becomes a condenser. So instead of running 85, 95 degree air on there, we're still running 70, 78 or whatever degree air across, which is almost 20 degrees lower. That's going to lower the head pressure. The evaporator's outside with, say, maybe 20, 30 degrees entering air on that evaporator, as opposed to the 70, 75, or 80 degree air inside in the summertime. So both sides are going to be considerably lower because of the entering air temperature. And when you start working on them, you have to keep that in mind. The tendency is to expect in the heating mode both the high and the low side to be the same as it would be in the cooling mode. And so what you need to do is keep that in mind, because the tendency is to overcharge the systems and whatnot. Now, we covered that. Then what we have to do, they have another question, or several questions. Why is it more important to have a clean filter on a heat pump in the heating mode than it is in the cooling mode? Well, the air filter is, of course, filtering the air going across the indoor coil. In the wintertime, that indoor coil is a condenser coil. So if I restrict the airflow, I don't cool down the condenser as much as normal. It's going to raise the head pressure. And in a lot of ways, the customer likes that because it's warmer air. But it's detrimental to the system when it can't reject the heat that it absorbs outside. So you have to sort of keep that in mind, because if you don't change the filter, you might like the heat a little bit better, but it's detrimental to the unit and is going to raise the electric bill. If it gets dirty in the cooling mode, the coil will ice up, and then they know have trouble. So it's a little bit difference. Then one thing also to note, in the heating mode, both of the service valves, both the large and the small line coming off the outdoor unit, are the high side. So that little service valve that you see coming off the suction line near the accumulator, there's going to be a lot of units. It's between the two lines on there. Train company's a little weird. I almost made a mistake once on it, thinking that it was an air conditioner, because I didn't see that extra little fitting there for the suction side. But when you take the panel off a train unit, the reversing valve and whatnot is right there, and that middle line off of the reversing valve is the true suction, and it's connected at that point, so you can access the low side pressure in the heating mode. You can also access it in the cooling mode. And when you're in the heating mode, put your high side on the liquid line. You just don't want to be putting your gauges off and on the hot gas line, because it really sprays and can be a problem. So that's pretty much, I just want to review things there. So we did the reversing valves and everything. So you understand it, and hopefully this helps. Probably going into Thursday, Wednesday time, I'm going to start on the heating systems, but specifically boilers. When I get through with you, you're going to know more about boilers than the average guy out there, because a lot of the companies don't service boilers, whether they're steam or hot water, and at least you're going to know there's more to it than just make sure the boiler heats. So I'm going to sign off for now, and I'm going to try to get this posted. It is Tuesday. I'm going to try to get this posted at night, and it's going to be on YouTube one way or the other. The other one I sent out to my other class, it turned out to be a URL on the email, an HTTPS thing that you would click on, and the video would come up. But this is going to be a YouTube. All right, have a good one. Talk at you later. Good timing. The phone is ringing. Ha ha.